Hello everyone. So basically, I've never seen the American and European models so similar in their solutions like this. Like, they're pretty much exactly the same. With the storm for Wednesday, Tuesday into Thursday, basically that time period. Tomorrow into Thursday. Mainly late Tuesday into Thursday. So, alright, here we go. So this is your disturbance. This is the American model coming into the Pacific Northwest. That is going to move southeast. And then a portion of that stays to the west. Another portion of that is going to come east and combine with sort of like another northern disturbance coming down from Canada, sort of like a clipper system. These two disturbances are going to combine eventually. So that's where we were. And it looks like this piece is going to stay ahead of that piece for a while, which is going to kind of keep it going north rather than south if these two pieces combine earlier. This is kind of trying to dig south, but instead this is kind of keeping it northward. So this piece here is kind of keeping the northern piece northward, otherwise they would try to dig south if they combine earlier. But that is not what is signaled here. Alright, and then they come together and they really strengthen. Alright, so again back here, it's tilted in such a way that it'll be taking Gulf moisture and Atlantic moisture at the same time. Okay, your jet stream is going to be all the way down here, but not far enough south for this to come down and come up the coast like that. This is going to be on land, and it's going to track north of southern New England, unfortunately for those of you who wanted a big snowstorm down there. Okay, so then this is going to move off the coast, and there it goes. Okay, so let's look at what the GFS has for the track. So this is where these brings this piece of energy east. It comes ahead of this and keeps the northern part of this from digging further south. Okay, so the storm's going to form here and move due east and then start to shift northeast as it comes into a flow of winds that's going to be pointing northeast, namely the jet stream. So here you go. We're going to look at our low map. There's your storm forming, and as these two pieces of energy come closer together, this is trying to move north, so it's going to strengthen the storm and it's going to start to move northward. Okay, so let's watch here. Sorry, I keep forgetting where we were. This is where we were. Okay. Actually, no, this is where we were. So then it starts to strengthen, as you see. These two pieces come closer together. Starts to track more northward. This piece is tilted kind of negatively, so that's why it's taking a northward track. And also the jet stream is pointing it up that way, towards that way. The jet stream, again, is not far enough south to bring this down here. So that negative tilt is going to, one, allow it to take in moisture from both bodies of water and move it northeast. Alright, so there's your storm. And there it goes. It tracks just north of Long Island in New York City. Just north. And look at that. We go from 990... I can't read that, but I think that's 990. Alright, down to 984 or 986. And then down all the way to 980. So this is going to be rapidly intensifying as it moves, and the reason for that is because you have an Arctic air mass that's going to be trying to work in. As you can see, you have the high pressures up here that are going to be rotating Arctic air in here. However, this it's the high pressures, the Arctic air mass is setting up a little bit too far to the west, so the Arctic air is not going to come as far south as southern New England. It's going to stay to the north until the storm moves out. However, you're still going to have a boundary here between warm and cold air, and as the storm hits that boundary, and you have wind energy coming in from the jet stream, plus you had the northern the northern disturbance come in to combine with the southern disturbance, all of that together is going to strengthen the storm as it moves northeast. So three things are strengthening it. One, is absorbing moisture from two bodies of water. Two, you have a boundary between warm and cold air stretching out here. That immediately creates lift, which also intensifies it. And you have the two disturbances coming together to form the one storm, which also intensifies it. So those are the reasons it's going to be intensifying. Now look at this. This is a really potent storm. And what's going to end up happening is, when you have a boundary between warm and cold air, the temperature difference creates what we call lift in the atmosphere. So when moisture's coming in, it's going to be rising rapidly above the cold air, and it's going to form heavy snow on the northern and western side of this low pressure here. So your heavy snow bands are going to be across northern New England. For the most part, you're probably going to get more rain south of here because that Arctic air is not going to work in time because this Arctic air mass is just not placed properly. For this to be a major snowstorm further south, the high pressure would need to be on top of this to have it go further south. But that is not the case. Okay, so that is the American model, and the European model is pretty much exactly the same thing. Okay, so if you come in here, again, there's your piece of Pacific energy. It's going to move east. Alright, so then a portion of this is going to combine with the northern disturbance coming south from Canada. There you go. This one kind of combines it earlier, but the solution actually kind of turns out the same, believe it or not. So then this southern disturbance is actually going to try to push it north. That's why this northern disturbance is trying to dig southward, is not going to be able to. So there you go. And the European does bring it a little further south, the disturbance, but the storm itself has pretty much the same track as the American model. So if you take a look here, so this is the storm forming as these two pieces of energy come together over here, and that's going to strengthen it, and again it's taking in Gulf moisture, so that's going to help to strengthen it as well. So there it is, and then when you go to the next run, bam, it goes from that to that, that to that, oops, I'm sorry, that to that. And if you remember, that's exactly pretty much the same track as the GFS, the American model, took from there to there. And again, 980, it's the exact same central pressure too. So I've never seen both models so similar in solutions. Alright, so again, you're going to be taking in the moisture here, boundary between warm and cold air up there. Your heavy snow bands are going to be on the northern and western side of that. This doesn't track far enough south to let the Arctic air come further south, so areas in southern New England and south of there, you're going to start out as rain, and then what's going to happen is, alright, so this is Wednesday morning. So, oops, I'm sorry, hold on. These areas are still warm, south of the darker blue. You're all warm, okay? So areas to the north, you're already going to be cold, so you'll be getting snow the entire time. Now as this moves east, this is Wednesday evening, you're still warm in this area here, and then areas to the north and west, you're cold. So see, the problem is because this comes north, your Arctic air is not coming south. It's rather, this storm is kind of shoving it back up north. So it's going to come in behind it, but very rapidly. Alright, so while these areas here are going to start out as mainly rain, on the backside, oh, and by the way, these areas here in northern New England, you're going to be all snow. And you're going to get some major snow accumulations. We'll talk about that in a minute. And then this is Thursday morning. Look how quickly that's moving out, and look how quickly the Arctic air rushes in behind it. That's really quick. This Arctic air mass really wants to try and, come in. And the main thing, though, that I'm noticing is that as this moves offshore, the precipitation is going to rapidly move away. So I don't think you're going to get a long period of snow in southern New England, Long Island, New York City. I think it's going to be mainly rain until about midnight, then it's going to change over, but it'll be a really quick period of snow. And that's going to give you lighter accumulations. Now, as this moves up the coast, look at how strong this Arctic air mass actually is pretty strong. Sorry, this Arctic air mass actually is pretty strong. So as it moves up the coast, taking in moisture, creating lift in this area, this is going to continue to intensify as it moves northeast. So you're going to get really heavy snow bands on the northern and western side. So these are where my heaviest snow accumulations are, and I'll show you in a minute what I mean by that. Okay? So I think that's all I wanted to show you here. Alright, now we can get to, I'm trying to think. There's one more thing I wanted to show you. I want to look at the American model for the precipitation map. So here we go. There's your precipitation map. So let's go all the way to Wednesday. So this is Wednesday. Early in the day, your precipitation's moving in. There's your storm. That's going to move northeast. So here we go. Notice how most of the heavier precipitation stays to the north and east of southern New England. There's your storm. Notice how, because it's going to be absorbing moisture coming in, it's going to be absorbing moisture from the Atlantic. Most of your lift is going to be along this black line here. That's the boundary between warm and cold air. So your heavy precipitation is going to be on the northern side. The southern side, there isn't going to be as much lift. Okay. So as you move ahead, now you're on Wednesday night, going into Thursday morning. Watch how quickly it exits. So my concern is as the Arctic air moves in, all the heavy precipitation is going to be gone for these areas down here. So you're going to be mainly rain and then just going to get a light period of snow at the end. Okay, so that's what we're seeing. Now, in my opinion, even though this storm disappointed me by going north, I was really counting on this to be a big snowstorm for southern New England, Long Island, New York City, where I live. So I am quite disappointed that the Arctic air mass couldn't come in quick enough to shove this a little further south. And I'm also a little disappointed that the jet stream didn't set up further south. But irregardless of that, whether or not it's a heavy snowstorm for southern New England, it is going to be a very big snowstorm for northern New England. I think this is going to be a storm in the record books. Well, not like, it won't be anything like the Great Blizzard of '88 or even last year's blizzard, Winter Storm Nemo. But some snow amounts might come close to tying. So I think this is going to be the storm of the winter for northern New England, basically. Okay, and now I'm going to get my interstate map up so I can start discussing snow accumulations here. Alright, so we'll do that in the next video. So you've seen the setup, you've seen the models, so now we're going to talk about impacts of the storm. Alright, thank you for watching.